Um, yeah, hello. Today we're going to have some random updates and some arcs, and let's get straight to it. This is basically normally a three-phase under voltage. It basically switch, or if one phase missing, it disconnects. But I was modified so it can now run on single phase, and I was make a little circuit board here, and I was rewind the coil. And first I'm going to show you the schematic and then how it works. You can see here the schematic. It's very simple. It's a capacitive dropping power supply. We have here two class A X2 0.39 microfarad capacitors and a 680k discharge, 5.1 ohm fusible resistor. Ideally it should be a little bit bigger, but yeah, that's what I was find. And of course the 1N407 standard bridge rectifier, and here is a little 0.68 microfarad smelting capacitor to protect the rectifier a little bit. Basically mains comes in here, and low voltage, low current comes out here for the coil that I was rewind. The original coil was 400 volts AC, the new coil is like 5 or 6 volts DC. It's much more efficient than the AC coil because the DC needs much less DC current to hold it in than the AC. Yeah, let's get to it. I'm going to turn on the power supply, set to 240 approximately. It shows this, but actually it doesn't draw any current now, it's just a meter. C volts, and this is a basic step up transformer. That's just for a test. And yeah, as you can see, it stays in, and basically this is a little 4 amp thermal fuse here for the transformer. It's a 232 like 380, 360, 400 volts, something like that transformer. And I'm going to slowly decrease the voltage, and you're going to see when it will just suddenly will drop out. Not yet. And there it dropped out, and if I crank it up again, roughly to 30 to 40, doesn't go back on. You have to reset it by pressing the start button, and now it runs, and you can of course turn it off at any time. Yeah. A little update also on my little power supply. The 0.06 amp fuse is actually not enough because it was a fast blow, it just blew from the inertia. But now a slow blow 125 milliamp, that works better. Still enough to protect the transformer in case of short circuit. I also find this little meter, so see that again in action. Turn on the power supply. And as you can see, you can nicely vary. I think I will add, once I make an enclosure for this power supply, I will add this meter without a battery, just for a test. Yeah, it's a nice meter. A lot of decimals there. Or behind the decimal. Yeah. And yeah, I will do that later. I will pause quickly, and then we're going to make some arcs. Oh, I almost forget. I was modifying my ring light because the USB was get wired too hot. This like DC jack, and well, this gets a little bit warm, but it's not that bad. Mostly it's probably the cable is a bit thin. This is stone gold. This is a nice mineral. Also, it's like a little bit warm, but not like hot like the USB, so yeah, that's better. Yeah, let's get to the arcs. Yeah, here we are again. Similar setup as last time. Transformer, capacitors this time, and same welding transformer step down. And yeah, let's make some arcs. Let's give it, let's try 890 volts, something like that. Let's see what it's going to do. Nah, not so big. Let's give it a little bit more. By the way, that's like 63 on the primary of the high voltage. Oh, that's much better. The resonant capacitors are doing a good job this time to make the arc nice and big. Of course, everyone wants to see this. More arcs. It's like 2.5 kilowatts power. Very impressive arcs. Start off. Of course, always discharge the capacitors, just to be sure. Yeah. Shrink it down. It's off. Nice little setup. And a nice 32 amp, and that was like 50 or 60 volts into this transformer, and as you could see, very big arc. Yeah, thanks for watching, and see you soon again. Bye.